Evening, everyone. Thanks for signing up, and obviously a massive thank you to Ken for being with us this evening or this afternoon in his time. A few words, just a bit of background then. For those of you that don't know me, my name is Barry Cranford. I'm the founder of the London Java community and one of the organizers of the London Groovy and Grails user group. So I'm not a developer myself. I run a tech recruitment company called RecWorks. Here at RecWorks, we've been on a mission for the last 12 years now to find ways that recruitment can be a force for good in the tech industry beyond just getting people jobs. And that's specifically been around learning, mentoring, and career development and that kind of thing. So what we try and do is create groups and platforms where we connect people that want to learn and people that are happy to share. So that can be on a group basis like this evening, and through communities like the LJC and the Groovy and Grails user group. Or on a one-to-one level, which is usually done through the Meet and Mentor community. So we've made about 2,500 introductions now between mentors and mentees for all sorts, from becoming CTO, becoming a speaker, learning more about Groovy or anything. So if there's anything you're personally interested in learning more about in developing your skills around, then feel free to sign up. It's all powered by revenue from recruitment. So again, if you're looking to hire, then please do bear RecWorks in mind. Anyway, on to today. Ken Kousen is a Java champion. He actually spoke recently to the LJC and we had some superb feedback, hence why he's back here. He's also a Oracle Groundbreaker ambassador and a Grails rockstar. The author of the books, the Kotlin Cookbook, Modern Java Recipes, Gradle Recipes for Android, and Making Java Groovy. And he's a regular speaker on the No Fluff, Just Stuff tour. He also teaches training classes in areas related to Java, including Spring, Hibernate, JPA, Groovy, Grails, Gradle, and Android. So Ken, I'll hand over to you.
Oh, well, thank you very much. I appreciate it, Barry. Just to let everybody know, I am keeping an eye on the chat box. So if you decide, I mean, you can use the mic if you like. I don't think anybody's restricted from doing that. But if you decide you want to type something in the chat box, I have to remind myself to look up, but I should see that as well. These slides are not yet available, but there will be. What I'm probably going to do is, as soon as the presentation is finished, I may do a little bit of cleanup on the slides, and then I'll add them to the GitHub repository. So I'll give you the link to the GitHub repository. Well, in fact, why don't I start with that? Here's the current form of the slides, and forgive the spare nature of them. They're just, black on white, very, very simple. But I'll give you the GitHub repo as well. By the way, here's my contact information. So you're welcome to contact me whenever you like. There's my email address, homepage, blog, Twitter handle, and I've got a free weekly newsletter if you're interested as well. And the GitHub repository is going to be this one. Here, let me copy that and paste it into the chat box if that's of any help. Now that's ready. There's code there, but I plan to do a couple of examples that aren't in there yet, and I may add some stuff to that over time. It's got a Gradle build file. It's got some Spock tests, and I'll show you the GitHub. I'll show you the Gradle build, and I'll show you that I'm using, Groovy 3 obviously, and the Spock 2 milestone version. So I don't think they're up to release candidates yet, but Spock 2, milestone 3, Groovy 3. So you'll see the coordinates there. And because Spock 2 is based on Java 5, all the tests ultimately require Java 5. Now that automatically adds the Java 5. Boy, we're off to a good start. JUnit 5, sorry about that. So Spock 2 is based on JUnit 5, which is nice. And that repository, or that dependency, gets added automatically. We don't have to worry about that. But I did have to add the little block inside the Gradle build file to say that we're doing JUnit 5 tests, and everything seems to be working fine there. So, but again, feel free, ask questions when you like. I see there's a couple people in the list that I know. It's good to see Jakob Mikkelsen again. That's wonderful. And oh, Eric's here. Great to see you. And of course, Bill Fly. So I hope you like my background there, just with the Groovy logo. Let me start getting into some of this stuff. Okay, so a lot of what I'm going to talk to you about, yep, hey Eric, a lot of what I'm going to talk to you about is based on the release notes that come from Groovy 3. I have a couple of somewhat larger examples. They're not enormous or anything, but there's a lot of stuff in these release notes itself. In fact, why don't I give you that link in the chat box here? And that is this page right here, the release notes for Groovy 3. I'll magnify that now. I mean, I'll lose the menu on the side, but it doesn't really matter. And what I've done is I've taken a lot of these snippets and just basically pasted them into the slides. But I'm going to show you in the GitHub repository a lot of code examples, and that's really what I want to focus on is the code here. I think what you'll find is that Groovy 3 really isn't that different. There are some really interesting changes and some nice updates. But if you're just a user of Groovy, then you're not going to have to radically learn massive new stuff. Groovy's pretty stable. There's just a few interesting little additions, things that didn't work before. And probably the biggest thing you'll notice is that the Java syntax for lambdas and method references now works in Groovy. Prior to that, we always had to use Groovy closures whenever they wanted a Java Lambda in the API, but now you can actually use the Java Lambda syntax and everything works there. So that works in pretty much anywhere in the library that's expecting one of those functional interfaces in Java. You can now actually use the Lambda syntax if you want. I am going to show, that fancy Groovy background. All I did is I went to the, I'm trying to remember where I got it. I think I actually went to the Apache Groovy group and downloaded the logo and just set it as a JPEG or PNG file or something as my background. So I just got it from the Groovy site. It's not mine or anything. And I don't remember exactly where I got it, but it's just the standard logo on the Apache project right there. So one thing again is that we're able to use the new syntax. There's a lot of other additions that were there too, but some of them I think you'll find it's actually better to use the associated Groovy constructs. Like, okay, hey, it was always an odd thing that the one Java construct that did not work in Groovy was do while loops, believe it or not. You could not do a do while loop in Groovy, and it's not like I ever missed it or anything, but here is the little snippet from the release notes, and you see they actually have a do with a block and then the while after it. So it's a loop that always works at least once. So it's a typical factorial example, and I'm going to show a couple other functional examples. Now I do want to show some examples that are functional programming ones, and not all of that came from Groovy 3. Some of those come from earlier versions of Groovy, 2.4, 2.5. But I'm seeing that some people in the Groovy ecosystem are not really aware of some of the changes that have been made over the years, and it'd be nice to have a handful of examples. I'm also going to show, if we have time, one really old example, which I've updated to work with the current versions. Alvaro Sanchez, if that's the Alvaro, I think. At any rate, I should hit the admit button for another person. Any rate, I have a really old example that works with what they call refreshable beans in Spring. And I've always been amazed at how few people either in the Spring side or on the Groovy side are even aware of this. And what I had to verify is that it's still working even under the current version of Spring and the current version of Groovy. And it does, believe it or not. So I was really surprised. This is an example I've been doing for several years, but many people are not aware of it. So I thought I'd show a demo. Any rate, again, the GitHub repository will look at this code here. This is my Groovy_3_ examples repository. I'd magnify this, but I don't think the magnifier works under Zoom, so I just have to tell you in many cases. If that font is not big enough, please let me know, and I could always magnify that a little bit. Of course, here I could just pinch to zoom, but in general, I can make the font bigger. So this is a regular old project. This is not particularly a Spring Boot project or anything like that, just a regular project using the Groovy plugin. I'm getting all my dependencies from Maven Central. One of the things that has changed in Groovy relatively recently, certainly in the last year or two, is that instead of just automatically including the Groovy all dependency, now they have really gone to great lengths to modularize Groovy. So this is the basic Groovy dependency, the minimal stuff, and then each additional library has a dash after it. So if I just hit Control Space after that dash, you see there's, these are ones I've done recently. They propagated to the top. The XML stuff is in a separate module, and JSON and some of the testing and SQL. Date time is the one I added because I wanted to use like local date and stuff. The swing stuff is still there, and a handful of others, as you can see if you go through them all. So I didn't try to do an all or even an all minimal. I only included the ones I use directly in this repo. And if I add more stuff to it, I will individually add them. Another interesting thing that's happened is the Spock people, this is presumably going to get announced when they move to the release version of Spock 2. They now have a BOM, as they say, a bill of materials there for Spock, so that I could put the platform here with the version number. This is what I was saying for Spock 2, milestone 3, based on Groovy 3.0. But the benefit to doing it that way is that then I could just say, oh, I want Spock's core and say Spock Spring and whatever, and not have to put a version number on there. So it's not really that fundamentally different, but it works. And it was, I thought it'd be interesting. This is the part I was telling you about, however, because Spock 2 is based on JUnit 5, I have to add this use JUnit platform configuration to the test block. And that way it will detect all of the existing tests. Just to show you the thing running, first of all, just to prove a point, my Java version is I'm running on the JDK 11. Oh, I switched to the Grails JVM. I forgot I did that. What the heck, I'll go with it. So it's just any implementation of Java 11 at the moment. You still only require Java 1.8. You could do everything you need to under 1.8, but I thought, what the heck, let's go to the current release version, the so-called long-term support version, and make sure that's working fine. And my Groovy version at the moment is 3.0.5, and as you see, running on Java 11, and I'm using the Grails virtual machine. There was a nice YouTube video that was created last week by Szymon Stepniak, Szymon Stepniak, who's Polish and has put together a nice video on YouTube on running Groovy scripts under Grails. So he used the native image compiler under Grails VM to speed everything up. And it really is very impressive. So I meant to put a link to that. Maybe I'll add it to the slides. Anyway, what I was planning to do, by the way, I'm using a Gradle wrapper that is the current version of Gradle 6.6.1. And if I do a clean and a build, I'm presuming all the tests are going to pass now. And the one thing you also may not have seen or be aware of is this cute little piece in Gradle, this test logging with events passed and skipped and failed. And you notice that when I use that, I can now actually see output of the individual tests right in the Gradle output. Sometimes I like that. Sometimes it gets old, but if you haven't used it before, it's kind of a cute little mechanism. In fact, I borrowed that from the Spock example project. It's been updated to use that, and I thought it looked kind of neat. So, more value added for coming to the presentation this evening. Okay, so let's go back here. So I was now talking about the do while loop with the classic Java style. And again, this is basically just copied out of the release notes here. And it's not like I have any plans to use the do while loop, but hey, it's there now. The other thing that was added is this Java for loop. Now I remember when Groovy was shiny and new, I guess when I encountered it was probably back around 2007, I guess. And I think Groovy was created around 2003. Paul King wrote a great article on the history of Groovy. I have to find a link to that. I'll have to add a link to that in the docs as well. And the only problem I have with that history is, boy, he wrote like 30, 40 pages. I haven't read the whole thing. So I'm looking forward to digging into that. But Groovy was invented roughly the 2003 timeframe. And it really started to catch on around 2005 or 6. And partly what helped that was the whole Ruby on Rails phenomenon, that basically demonstrated you could build what we would today call well, maybe not microservices, but web apps and microservices in a very agile fashion. And when we wanted to bring that functionality, pardon me, into the Java world, well, Groovy was just sitting there as the language that allow you to write code, that writes code, and it works with Spring and Hibernate. So Grails was then created, and that brought Groovy into much greater prominence at the moment. Any rate, what triggered that discussion is that when Groovy was first created, they didn't support Java for loops at all. They just had the regular Groovy for in loop. And now, then later they added in the regular traditional Java for loop. Well, now you've got this mechanism where you can put in commas and, you know, initialize multiple variables here and increment multiple variables in odd little ways. And this works as well. So these are factorials again. So they're starting at 1 with I as 1 and then incrementing over the count where I is incremented until we hit 5. And this is saying, create the factorial by multiplying each one by I. So you can see there's the results of the factorials up to 5. Another really interesting addition, and again, this is all in the motivation of making Java people have an easy transition to Groovy, is that now you can initialize arrays using the Java style array mechanism. You can go new int array and give your initial values here, and that works fine. So these are primes, and you can say the size is 5 and do the sum and everything. And if you look at the name of the class, it's that weird mechanism that Java has for arrays. So that works. So here's a string array as well. And of course, the Groovy alternative would be to just use the square brackets and assign it to a string array. The only problem with this is that that might run into difficulty if you're doing a compile static, for example. So compile static tends to cripple this mechanism of saying, look, I'm just going to make something and whatever I assign it to is what it is fine. But with traditional Groovy, this of course still works fine, and you can use every methods and things like that. Just as an aside, what I've always liked to do as a demo, boy, I got a lot of samples here. Here is the Groovy console, the current one. What I've always liked to show Java people, for example, is I'll do something like this. Oops. This is a list of strings dot split. And in Java, the split method takes a delimiter, a string, to represent the delimiter. But in Groovy, they added the split method to string in the Groovy JDK, and what it returns is in fact an array. So if I was to say def strings equals, and then I wanted to print out not just the strings, but I also want to print out strings.class.name, then you get that weird syntax showing an array like this, you know, the square bracket, capital L, string, semicolon, to indicate that this is an array of strings. But if I don't want it to be an array, if I just want to go, hey, this is a list, hey, now it's a list. But that's the dynamic capability of Groovy. That's the sort of thing I love to be able to do. And again, the only thing that would stop that is if I threw a compile static on there. If I wrap that in a method and put a compile static on it, then it wouldn't be able to do that anymore. And with that in mind, of course, now we have this array initialization syntax if you want it. I still don't have a use case for it, but I'm just showing that it does exist. Okay, another feature that comes with the new Parrot Parser, and this is, as I say, this is the one that's going to get the most attention, is the fact that now we can use Java Lambda syntax. So in Groovy, of course, our closures are always surrounded by braces. But in Java, we have the variable and an arrow, and then this, pardon me, this would be a block lambda, where they surrounded the implementation in braces, whereas this would be an expression lambda, where we just put a single expression on the right-hand side, and whatever that expression returns is what the lambda returns. This is also a nice illustration of something that I've relied on for many years, which is that in Groovy, they added methods like, well, find all and every, like they showed on the previous one here, sorry, going back, this every method and everything, those are added to collections. And the methods on collections will therefore operate in the traditional manner. They will process every element of the collection before they go on to the next chained method call. So if I did a filter followed by a map, well, of course, the Groovy equivalent would be a find all followed by a collect. Then it would do a find all on every element and then a collect on every element. And of course, Java streams are not like that. Java streams are lazy. They process every element of the stream through the entire pipeline one by one before going on to the next element. So in this streaming code, this would take the 1 and say, are you even? Well, no. So then go to 2. Are you even? Yes. And then we'll double it using the map method and producing a list. And now we have a 4, etc. So if you wanted the lazy behavior, so-called lazy behavior of streams, the question was, well, how do you do that in Groovy? Well, you do that in Groovy the way you do it in Java. You just invoke the stream method and just use the Java library that already has that mechanism built in. So the thing that's different is we used to have to do filter here with a lambda, with a closure, rather. We would wrap this in a traditional Groovy closure. Now, there's a bit of an advantage to this. If I went 1 to 10, well, for example, all right, that's getting old already. So let's do this. So if I went 1 dot 10 dot each, and then, well, I guess they went and turned it into a stream. But if I just wanted to do a dot find all, it mod 2 equals 0, for example, then again, that's operating on all of them. And if I wanted to do the dot map, which unfortunately has the collect method on it, and then that doubled them all, and then I could do dot sum, and there we are. You know, it's nice and simple this way, but this is not the lazy behavior. This is the eager behavior, in that it's doing a find all on every element and then a collect on every element that remains and then the sum. Whereas if I want the lazy behavior, I could do the stream, and what we used to have to do is to do a Groovy closure on this. So again, if I'm just thinking in terms of Groovy closures, oops. And then now, by the way, notice this time the sum will fail. And the reason is that this stream produces a stream of integer, not an int stream. An int stream doesn't have a sum method. So I could do a reduce operation here, or more likely, I would change map to int, which would convert to an int stream, and that does in fact have a sum method on it. So this would be the, I kind of sometimes think of this as speaking Java with a Groovy accent, if you will, because this is really Java code, but by adding the closures here, you basically are doing Groovy code in there. Of course, the equivalent now is that I could write a lambda and say n arrow n mod 2 equals 0 as an automatic, just that's a lambda, an expression lambda. And then again, I could go n such that n times 2 here and get the same answer out. And that really is just straight Java. That just happens to be written inside Groovy, interestingly there. Another neat feature, by the way, other than the sum, is that one of the things that I've always said to people working with Groovy is that if you don't feel like working, you know, if you're bored, you don't want to do your regular job, try browsing the Groovy JDK. You know, the Groovy JDK has tons of really neat methods in it. And they now have, as part of Groovy 3, the Groovy JDK has been enhanced as well, although some of the enhancements I'm going to talk about go back to 2.4 and 2.5. Well, Stream now has methods in it too. So for example, if I stuck with map here and I wanted to convert this to a list, in Java, I'd have to write collect, again, there's collect, and collectors dot to list like this, and this is going to fail because I need the right import statement, and I'd have to go find what package collectors was in. And that would be kind of annoying, although in an IDE it would be easy. But guess what? In Groovy, they now have added the toList method and to stream as well. So all I have to do is say toList or toSet or even toArray. And with toArray, I think the argument to toArray turns out to be a class name. So you can make an array of a particular type. And boy, isn't that easy again, which is just so typical of Groovy, is to take something that works in Java, but it can be kind of annoying, and then simplify it in Groovy inside there. So back to here. So this was the regular toList method. And I remember when I first saw that, I went, oh, wait a minute, did they really do that? And here's the proof, by the way. Here is the Groovy JDK, and you'll see under interfaces now, I can go down to stream. Let me magnify that. That's probably not projecting real well. Oops. There we go. And you see that we have toArray to a, oops, oh, I'm getting a lag. toArray to a particular class type, or toList, or toSet, and accumulates automatically. Those methods are actually up from base stream. And it's also got with closable in it. So if you pull your data from a file or something like that, you could just chain on a dot with closable. That reminds me of another feature that was added with the Parrot Parser. This is something I, again, don't know that I'll use because Groovy has better ways to do this. But in Java, they introduced try with resources in Java 1.7. So that you could put parentheses before the braces in the try block. And if any variable you create in those parentheses comes from a class that implements AutoClosable, Java will automatically close it. And you don't need a finally block. Well, part of Groovy 3 with the Parrot Parser is now try with resources works in Groovy as well. I don't have an example of that in my code, but, sorry, back here. Here's an example of it. Try with resources. So here's an example. What they show here is this is a byte array input stream, if you will, and you have to have a close method because the AutoClosable interface has a close method. So in the byte array input stream, they created their own resource that extends that and has a close method. And the same thing with the byte array output stream. And then down here, they're able to put in the try with resources. And he wrote it vertically. Notice the parentheses here that instantiate both the to resource and the from resource exactly as shown. And because they implement AutoClosable, because they have a close method, then all you have here is a try without a catch or a finally, which of course looks really weird. You know, as someone who's been in Java a long time, that's always looked bizarre to me. You know, but you could do that in Java as long as you don't throw it, as you put your exceptions in the signature or something like that, say throws IO exception. Of course, as we know in Groovy, all exceptions are unchecked. So they were able to just leave out the catch block. But what's really missing that would normally be here is the finally block. And now that's no longer needed. And it's interesting that in Groovy now we could do that as well. The thing is that this is going to a lot of trouble to do this. Whereas in reality, in most classes that do any real IO that need to be closed, you have with methods like with closable or, you know, with resource or something like that, that automatically close the file or whatever when you're done anyway. So there's, as I say, it does work, but there's generally an easier way inside of Groovy on that. Okay, back to the slide stuff. Method references. This is a method reference syntax from Java, of course, is that here they made a stream of integers again, and they map them by invoking value of on string, so that basically that's parsing a string out of each of them or converting them to a string here and then converting it to a list. So okay, string colon value of, that's fine. I remember I used to do the wrong thing there is I used to go string colon new, although I didn't. What I did is I said new string of that value. And of course, if you're not aware, that's now discouraged. You don't want to create them unnecessarily. Value of with strings, and in fact with all the wrapper classes, will look in the cache to see if you've already created an instance of that particular variable and therefore use the one out of the cache. So that can be very helpful, and that's what they're doing here. They're saying let's map them to strings using value of, but that will also check the cache to see if it's been done before. This always confuses Java developers because this value of is an instance method and string is a class. So you're like, why are you using a class on the left-hand side? Well, the reason is that we are actually this is a static method, so that's inevitable. It's this one that's the instance method. 2 uppercase is an instance method on string, and yet we're using the class name anyway. And the reason is that each of these elements is not the argument to 2 uppercase, it's the target of 2 uppercase. You invoke A dot 2 uppercase and B dot 2 uppercase. So in Java, the rule is for method references, if you reference a method from the class, if it's an instance method, you're implying that you're invoking the method on each individual instance. Whereas if the stream elements were the argument to the method, you would use an instance reference on an instance. So just like system.out : println is what you use, because println takes the argument as take the instance as an argument. So just a side point, and the point is all this still works now in Groovy. So you don't need to, you can still use the Java code as it stands there. And I spelled method wrong. I was typing too fast. This one, I didn't bother copying the source code. This is just interesting. They've added a couple of operators here, a not in and a not instance of operator. So 42 is not an instance of local date, for example. Instance of being a keyword is all lowercase. It's always tempting to put a capital O on instance of, but no, it's a keyword. And that's your is method in other languages, like Kotlin would use is for that. And I don't know who had halfway through the talk as the over-under on when I mentioned Kotlin, so I apologize. At any rate, there's also a not in. Now, not in, of course, uses Groovy's contains method. In other words, the in operator delegates to the contains method. So not in is just checking that it's not contained within this collection as well. 33 minutes. So did you have the over on that, or did you have the under? Anyway, okay, here's another one that looks, oh, you had the under. So, hey, I was trying to delay there, so that worked out. I don't know if you won or not. At any rate, Elvis Assignment is new. And I have an example of it, but this is the one directly from the user, the release notes. So they're using the toString AST transform to create a toString value for element, which has a name and an atomic number. And then HE is helium, and may instantiate the element with the named argument constructor, which is fine. But what atomic number do you want to put on there? Well, that's going to leave the atomic number as a 0. And by using the with method, which is on object, that you've always been able to use with on Groovy objects with a block, and then access the properties directly. Another way to say that, by the way, is that the delegate of this closure is the helium object here, so that whenever it accesses something inside the closure, it'll look inside that object for the reference. So when they say we want to assign the name, or we want to change it to hydrogen, for example, or say maybe not, this is saying here, is the name not null, then use it, else use hydrogen, if you will. So that's the, oh, sorry, didn't mean to click on it. That's the normal Elvis operator, meaning we're going to assign name here by saying is name true by the Groovy truth, meaning not null, not 0, not false, not empty, if you will. So if it's not an empty string, if it's not a 0, if it's not false, then we'll use it, else we'll use hydrogen. So it's kind of the reduced form of the ternary operator. But here's the interesting one, is that you can actually simplify that now. Instead of having name equals name Elvis hydrogen, you can use this thing, which is Elvis Assignment. And various people have tried to come up with different names for that operator. And as bad as the name Elvis is, I've been reluctant to jump on the bandwagon for any of the proposed names. I'm not sure exactly what that looks like to me. It looks like Elvis who's been startled, I suppose, but I don't have a name for it. If you know of something and you get a proposal there, feel free. So this is basically doing an Elvis on atomic number, and if it's not null and not empty, just use it as the value. But if it is false by the Groovy truth, use 2 as the value. So it's a slight simplification. I'm not sure whether I like it. I'm not sure whether I'll use it, because I have a feeling it's going to bring up as many questions as it answers. I always tell people the goal of Groovy is not to make the shortest code possible. It's to make the simplest code possible that's still readable. You know, it really simplifies a lot of Java stuff, but I still want to be able to read it. But at any rate, that's Elvis Assignment. And when he invoked the toString method, of course, because name was not null, then it stayed at helium. And since atomic number was null, or 0 in this case, it became 2. By the way, this is one advantage that I think Groovy has over Kotlin. Kotlin, I don't want to say stole, so maybe I'll just say reused Groovy's Elvis operator directly, except it only works for nulls. So it doesn't check for zeros, it doesn't check for false, it doesn't check for empty strings or empty collections. It's only, is this null? If it's null, then Elvis to a default value. Otherwise not. And I find that not nearly as helpful. You know, I like Groovy's Elvis operator better, but you know, and it's not just because I'm talking to Groovy people. Groovy still falls in the category for me of being kind of a first love. I used Java right in the mid 90s and I've always liked it, but boy, I loved working with Groovy when I had the chance to do so. At any rate, so there's Elvis Assignment. Something that we also have now is a triple equals for the is operation. That instance of, instead we like to use is. So what they did here is he made a class called creature with a type in it and threw the equals and hash code AST transform on there so that you can make two creatures that are separate instances even though they're equivalent, and a third reference that is pointing to the first one. So copycat and cat are the same, which makes sense. I got a comment. Oh, wow. Marcin Erdmann is here, and he sent me a message saying that in doesn't delegate to contains, it delegates to is case in collection, which is really good. It's like, oh, okay, that makes a lot of sense. So thank you for that. So just for your information, because now it's for my information, I learned something today too. That's good. So at any rate, we have two references pointing to the same object and an equivalent object with a different reference, so that the equals method is true because the equals and hash code AST transform generated an equals method for us. And the equals equals operator, now again, normally equals equals operator would delegate to the equals method. So that's why this is also true, you know, because even though they're separate objects, they are equivalent, and the equals equals operator will delegate to the equals method. Or is somebody going to also correct me and say it actually delegates to the compare to method if the class implements comparable, but this one doesn't implement comparable. So I'm going with the equals method here. And now we have a triple equals, which delegates to the is method as well. So there's your is method, which has been around forever, triple equals, and then it's not bang equals equals equals, it's just bang equals equals. And what this is saying that these are in fact two separate objects. So the way I like to say it is triple equals is reference equality and double equals is equivalence. So that's how I express it. And if you haven't overridden the equals method, then the double equals delegates to the equals method from object, which is just reference equality. So at any rate, now we have triple equals and bang equals equals like that too. Both of those are there. Okay. This one, I'm still not sure what to think about this. This is really different, and it's called safe indexing on arrays. So notice they made a string array here in the normal way. You know, make a list and say, no, I wanted a string array out of it, and there it is. And now you can say question mark square bracket 1, which says, is the array not null? Then go ahead and access its second element, 0, 1. So that's a B. And here you could do assignment as well. You could change the value at the second element to C, and then when you access it, now it's a C. So now this has made the array null, and when you do the safe indexing operator on it, it simply goes, oh, I'm not going to call a null pointer exception, which normally the square brackets would invoke the get at operator. And get at on collections, it uses the index, and on arrays, of course, it's just a just straight array access. Any rate, geez, now I'm all self-conscious because I know Marcin was paying attention to what I was saying. You know, that one of the toughest talks I ever had to give many years ago. Remember the Spring 1, 2GX conferences? We used to have the Groovy and Grails conferences along with the Spring people there. And I was giving a talk on, quote, advanced features in Groovy. And who should walk into the room but Paul King himself? And I'm like, oh, great, you know? And what I had to rely on, which turned out to be true, is that the people I've met in the Groovy community are just incredibly friendly and charming. And you know, I didn't have to worry so much. But I mean, imagine trying to talk about, you know, it's like, oh yeah, I'm going to talk about physics and have Richard Feynman walk in the room or something like that. You know, that same idea. Of course, what he did is what I expected. He came up to me after the talk was over and he said, nice. And by the way, did you know you could simplify your code if you did this, this, or this? You know, that's how we all learn, I guess. But at any rate, back to this. So the safe access here says, well, the array was null. So even though you put the index value on here, we'll just return null. And when you try to do assignment on a null array, it just goes, no, 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 we're not going to do that. And it's still null there. So that was interesting, I found, as an interesting approach. So here they did a map, of course, a Groovy map with keys and values. And when you access the key, you get the value, not surprising. And when you could do the assignment as well using the normal, it's not really a set on a map, it's a put, but still. And then that works too. And the same thing with the nulls. So I like the idea because whenever I talk to Java people about Groovy, I know one of the ways to really get their attention is to simply go, just show them the safe navigation operator, just go question mark dot. And I mean, I've seen Java developers get tears in their eyes. They're so happy that they don't have to do the null checks for that. That, by the way, that's another feature that Kotlin just basically stole and filed the serial numbers off and added it to their language as well. So just interesting. But we've had safe navigation forever, and now we have safe indexing as well. It's kind of neat. I don't know. It just looks funny to me to have the question mark in the middle of the array access. But I imagine I'll get used to it. Cute though. Now, another somewhat controversial addition to Java came in Java 10. LVTI, they call it, local variable type inference. And in Java, you can now use, now I don't want to call it a keyword because it's not a keyword, var. And the reason it's not a keyword is that tons of people have used the word var for variables, right? I mean, how many times have you made a variable named var? And if they suddenly made var a keyword, they would just destroy tons of people's code. So they didn't want to do that. So instead, they call this a reserved type name. And it can only be used on local variables. So you can't use it on fields, you know, attributes of a class. You can't use them on method arguments. You can't use them on return types. You only use them on local variables. And that means the place where it's really useful is in like for each loops with big generic types or try with resources blocks, you know, things where you're repeating yourself on the left-hand side and the right-hand side. But it's still static. It's still compile time. It's still resolved to compile time. So at any rate, in Java 10 and above, and of course the current version's 11, when you say var2 equals, then it looks to see what the right-hand side is at compile time and infers the data type of 2 from that. TWO is then clearly an int in this case. But in Java, you can use that only on local variables. In Java 11, they allowed you to put var as arguments onto lambda expressions. Again, I'm not exactly sure what that's really buying me. I don't have a use case where I'm like, oh yeah, thank goodness I have var in the declaration of a field in a lambda expression. If you've got one, feel free to send it along. But at any rate, it is legal now. So this is an int function of type integer, which says final var of x is x times 2. And of course, we know 2 is an int here. So x is, well, inferred to be an integer as well. Again, I find that code more confusing than helpful. I'm not sure I would want to do that very much. And this doesn't really add anything. It just says, okay, we will apply that twice function a couple of times. Because it's an int function, its single abstract method is apply, and they're applying it to each individual element. A function has one value coming in and one value coming out, and then they're collecting them by, that's basically the map capability. and that's basically doubling each value. So we now have var. Now, among the Java people, I remember when that was first added to Java 10, I was really surprised at the reactions of most of the people publicly. Were like, oh, cool, I've wanted this for years. And I'm like, really? And when I talk to people in presentations and I ask them, there's always a handful of people who go, oh, that's great. And then there's a small but finite number that go, oh, that's awful. I hate that. I never want to use that ever, ever, ever. And, you know, I just kind of emphasize they're not making Java dynamic here. It's still compile time, and it's only on local variables, and it's just there when it makes your code really easy to read. Stuart Marks, by the way, is a core team member at Java, and he has what they call a style guide for LVTI. If you just look for that, if you just Google Stuart Marks style guide LVTI, he's got a nice discussion of when this is worth using and when it's not. But bringing it back to Groovy, now we see that as of Groovy 3 understands it. They understand what the var reserve type name means if you decide you want to use it. So once again, we're back to, hey, if I have a Java class and I rename it .groovy, will it compile? And we're really close. We're really close to yes on that. Another thing is interface default methods. In Java 8, they added methods with a body to interfaces. And again, that throws a lot of Java people. Now in Groovy, of course, what we have are traits. And in fact, I think the Groovy team leveraged traits to implement these interface default methods. And when I tried to play around with conflicts and how they work the way I resolved them in Java, it didn't come out quite as nice for me. So in this particular case, let me just quickly show you an example here of traits in case you haven't used one in a while. So here is company as a trait. So I have a trait called company, and I could have just put in a name property, but here, just to make it interesting, I put in a getName method that returns initech. And here is employee that also has a getName method that returns first and last name. But notice I could put attributes in a trait. See, that's the difference between a trait and a Java interface. Even Java interfaces, even though now they can have default methods in them, they cannot have attributes that aren't constants. They can't have state, as they say, if you will. So they're not they're not stateful. They still can only have, they have truly blurred the distinction between interfaces and abstract classes, but you can't do what you could do here. And in Groovy, I could put in attributes, and there's an abstract method as well. So the question comes down to what happens if I have a class that implements both traits. So here I have company employee implementing in both. And if you've never used a trait before, this is, they look like interfaces. You implement them this way. And for here's my abstract work method, you know, converting caffeine to code for money. Otherwise, you're a volunteer, I suppose. And if I didn't do this method at all, if I comment that out, you'll see that I get an error. And the error says traits company, comma, employee contain clashing methods with signature get name. So it says you want to declare an explicit implementation of the trait. And notice what they did. They used the super keyword to get at the one they wanted. Now, okay, fine. You see what I did is I wanted to use both. So my getName method says use employee's getName method. So Peter Gibbons, if you will, works for Initech. And there's your Office Space reference. Now in Java, I can do that with default methods and interfaces. In Groovy, I don't really have any reason why I would want to prefer default methods and interfaces when traits are available, you know, because traits are just so much more powerful and useful. Why not take advantage of them? So it's good that they're there because then Java code that uses default methods works. That's helpful. But honestly, if I had a choice, I would use Groovy in that particular case. Another inflammatory statement I would make, not along those lines, would be something like, you know, we're a small community, something like, in a world where Micronaut exists, why is there even Quarkus? What's the point, you know? But at any rate, moving on. So, any rate. There's a couple of new methods in the Groovy JDK. There's a lot, like there's an average method now on arrays and iterables, so that will be able to take averages for numerical values for you. There's a take between method on string and on character sequence and even on Groovy strings. There's a shuffle method there was always collections.shuffle that took a list as an argument. Now there's an instance method called shuffle on arrays and iterables, and shuffled can find out, I think, if it works. And by the way, local date has now been enhanced even further. For example, this is something that's been on my mind a lot. I don't know where you are on all this, but here is my days to election Groovy script. So this is basically just doing some java.time stuff. And I put in a pluralize to say if the number is 1, don't add anything, otherwise I'll return an S. So there's the date of the elections that are coming up in the US. And here's now. And you could always do an until method inside of Java to find out the number of days. That'll give you a period. From the period, you can extract. There's get years, get months, and get days. Here I'm just using the normal Groovy idiom of accessing a property and having it automatically convert to the getter method. But Groovy's got a minus sign. See, so I can just subtract or I can add if I need to. And when I execute this, then I could see how many days there are to the election. In this case, by the way, the minus sign tells you the number of days in between two local dates. For example, if I want the details of years, months, and days, that's why I went and used the period in order to be able to access those from the until method. So again, this is the sort of thing Groovy makes very easy because they do operator overloading in the java.time package as well. So that's nice, and look like I've got 63 more days to go. Moving on. I mean, I got nothing. A couple of functional things here, just to let you know. This is something that has been added in Groovy for a while. I think this was in 2.4 or 2.5. Actually, 2.5 wasn't a real thing, was it? I mean, yes, it was, but let's not get into distinctions. At any rate, Memoize has been around for a little while, and it's really nice. And does it say since? Oh, that's been in since 2.2. And the idea of Memoized is I can take a function that looks recursive, and what Memoized will do is it will build a cache of results. And the assumption is this is a pure function. So for each individual value, it always returns the same output for the same inputs. And of course, here it has no side effects as well. So that if I evaluate Fibonacci of 4, then I have to evaluate Fibonacci of 3 and 2. And of course, Fibonacci of 3 involves Fibonacci of 2 and 1, etc. Well, that results in a combinatorial explosion of calls. If I want to do like Fibonacci of 10 or 20 or 30, I'd rapidly run out of memory. Memoized will say, oh, well, if you want to call Fibonacci of 1, I will have a map where 1 is the key and the result of fib of 1 is the value, and fib of 2, 3, 4, etc. And it will save them in the map. And therefore, I'm able to do much higher values here. So here's my Fibonacci ones in a Spock test. And you can see I could do 9, I could do 100. You know, the values, if without the memoized in there, I would not be able to do this in any practical way. And you can see if I run it as a Spock test, you can actually see the values in here one by one. I just can't magnify it, unfortunately. But there's my factorial of 100, which that's the factorial. I didn't want to get to factorial. I was looking at Fibonacci. Here's the Fibonacci, which has the Fibonacci. The 100th Fibonacci number is whatever the heck that is inside there. Likewise, Groovy has this tail recursive annotation as well since 2.3, where if you write a function whose last evaluated expression is to call itself recursively, so that's what's going on here. I've written the algorithm for factorial by saying the factorial of n has n and an accumulator, which I will initialize with big integer .1. And therefore, I could say the result is if n is less than 2, then return the accumulator, otherwise called factorial of n minus 1, comma, n times the accumulator. So there's my accumulation on the factorial. And again, the idea is that on the test here, now I can do much, much bigger numbers that I would have been able to do otherwise. It's not a question of writing the algorithm this way. It's the fact that tail recursive causes Groovy to reuse the stack frames so that it can take advantage and not run out of memory on this. And do they say it that way? any rate, there's more documentation there, but this has been around a while and it's really nice, very helpful if you can write your code that way. There's also a memoized method on closures that'll do something similar, but here I'm using the AST transform. Okay, a couple of slightly bigger examples here. I don't have the real big one I wanted to show you. Let's actually create one. So here is opennotify.org, and it's got some APIs from NASA to consume data, like the number of people in space here. And if I click on this, you see that there's my URL, and they're doing their content negotiation right in the URL. And if I went to go to that, you would see that there are 3 people in space, and we have a number and a message, and people is an array of these craft name combinations. And when I show this to a Java person, of course, their first thought is to take this JSON data and plug it into a generator that will generate POJOs for them. I mean, we need a class to represent the combination of name and craft. We need a class to represent the big one. Of course, then I like to say to them, you know, that's a lot of work to go to. Actually, where's the URL here? Copy. All I really have to do here is say .toURL.text, and hey, there's the JSON data coming out of it. But if I want to parse that, if I want to actually get to it, let me add my import for groovy.json, if you will, .star. And now I can go def JSON data is a new JSON slurper. And the slurper, oops, missed the method here, has a parse method that takes many things, but one of which is a URL. So by converting to a URL there I have everything in a list of, you know, a map with lists in it. And in fact, I can do something like, say, print line, there are JSON dot number people in space. And you see that comes out, or I could go for each E in JSON.people, people here. Then I could print line $e.name aboard $e.craft. And there they are. I mean, this is the sort of thing we've been able to do in Groovy forever. And of course, I could then go, and if I really wanted to, map those to classes, and I just use Groovy Pogos, which would be really simple, and go on and use one of the libraries or what have you. But boy, that's simple. You know, it's nice to be able to do something like that. And it's going to take a moment, but let me show you this really weird demo with Spring. Okay, this is, again, totally optional. You don't need to deal with this if you don't want. This is in a separate repository I have called Use Groovy Now. I used to give a talk on the No Fluff Just Stuff tour called Use Groovy Now because I was trying to get these Java people to realize how cool this thing was in their midst, and I never quite got there. Let me show you this cool demo, and I'll end on this. So what I have here is a mortgage evaluator, and here's the evaluator interface in Java. It has an approve method that takes an application and returns a Boolean. And the mortgage application has things like the amount and the rate and the years and stuff. And okay, fine. But I'm saying, you know, say this is before the crash back in 2008. Here's my Java evaluator. Where's my Java evaluator? Yeah, I just returned true because, you know, that's what the banks were doing back then, which is what led to the crash in the first place. And that's all fine. Now, what I have here instead is my Groovy evaluator. And again, it's just returning true. But here's the cool part. Now, this is a Spring app. And I have actually, believe it or not, an XML configuration file. Now, I do have app config. See, I do have a configuration class. See, this would be my Groovy config, but I'm importing the resource. And the reason I'm doing it this way is that I have not been able to figure out in Spring how to use the lang namespace in Java config. See, they added a couple of tags like this Groovy tag in Java config, and or they added this Groovy tag in the lang namespace, and notice what this will allow me to do. This source is pointing to my file here. That Groovy evaluator is not in the class path. See, it's actually sitting under source main resources, not source main Groovy. This is just a script, if you will, even though it looks like a class. It's just a regular file. I deploy this source code here. Now, why do that? Well, because see this refresh check delay? It says, okay, every second a running Spring app will look at that file and see whether it's changed. And if it's changed, it will recompile it and add it to the application context. And as a result here in my demo, which is here, I'm going to get an application context on that app config, and I'll get the bean called Groovy Evaluator, and 20 times I'll call approve on null, because obviously I don't care what the application is, and I'll print the result. And if it's null, if it's not null, I'll say approved, and if it's null, I'll say denied, and then I'll sleep for a second. And what I'm going to do is I'm going to start this up, and then I'm going to go to the Groovy Evaluator and change this while it's running, while it's actually executing. So let me run this now. So I'll start it up, and you'll see it's going to start printing approved, approved, approved. And then everything goes bad, and we go, no, stop, stop. And now they're denied. And I go, yeah, I guess we're all right. What the heck? And now they're approved again. And how cool is that? I mean, what could go wrong, right? Let's edit our source code in production. You know, with no testing or anything. But at any rate, this is called a refreshable bean in Spring. And it's, think of it as, you know, what would I do in practice? Well, clearly I wouldn't expose that to the outside world, but sometimes you can't diagnose problems unless you're in production, right? I mean, unless something's actually under stress. Well, think of this as an intelligent meter or something. This is a source code you deploy inside your app so that you could say, oh, let's log this, and then watch a problem and say, oh, while that's running, let me just change to checking that, or something else. You know, I have something where I can modify the source code on a running app while the app is showing whatever problem I'm anticipating. So I think that's a really neat use case for an intelligent probe, if you will, or something like that. And yet it's just never caught on. You know, I mean, it is dangerous. I mean, the Spider-Man corollary applies, right? With great power comes great responsibility or whatever. But how cool is that? Yeah, production is exactly where things go wrong, and this would be one way to interrogate it and find out what's going on that as you're going. So at any rate, this is currently in my Use Groovy Now repository rather than the one I have, because I just wanted to make sure this was working before I moved it over. I can show you that in the Gradle build file, what I have in here is just Spring stuff, Spring context, Spring JDBC, and the Spock Spring testing as well. And everything else is just regular Groovy stuff. So if you're interested, it's a cool demo, and you're welcome to reuse that. Probably the best thing about it is it makes a neat little scary application in front of a crowd like this, you know. But if you look at the Spring documentation, they're all talking about Kotlin now, and they don't even really talk about Groovy anymore. If you look at the Spring Boot documentation, they kind of forgot Groovy even existed, even though, as you may recall, when Spring Boot was initially announced, the very first app that they used for Spring Boot was a Groovy app. It was a controller written in Groovy, you know, because it fit in a tweet. You know, it's like, here's your app in a tweet deal. So whatever, we still know it's around. We still know it's awesome. I still am always amazed by what cool things you can do with it. Is there anything else? I think that's probably everything in the slides as well. Yeah, there's a null check AST transform, but I haven't really spent time on it. And then again, what I was showing also is the single page documentation now off of groovylang.org has everything in it, and including a very good list of AST transforms. So there's some really great methods there. What I'm going to do is I don't think I changed the GitHub repo, so I think that's available. What I'll do is I can take those slides and upload them. But again, there's not much in there that isn't in this release note manual here, in case you want to. I should mention, I don't do these things, but some people do a lot of them. If you're the sort of person who likes to create their own AST transforms, they added this entire macro capability in 3.0.0, and it really streamlines the creation of those complex transform trees. Instead of having to create a constant expression with this or that or the other, it's this big complicated expression. You can kind of create those expressions with things that look like Groovy method calls now. So this macro capability really streamlines the ability to create AST transforms. I'm still mostly a user of AST transforms rather than a creator of them, but I really shouldn't just do all this on Groovy 3 and forget to mention that that is also another interesting feature of the language. Any questions, comments, words of wisdom? Heard any good jokes lately? Anything? I mean, at some point, the talk turns into just Groovy things you could do with Groovy, you know, which I think was the name of a talk that Graham Roche gave many years ago. I don't really have much else. I hope you get a chance to use it. You see, it's not really going to change your life, what they did at Groovy 3. Most of the changes are relatively easy, small, you know, they work nicely with Java. I don't think there's anything else in here that we needed to talk about, but it's good that it works now. Yeah, they're the GDK ones as well. I think that's pretty much it. If you're looking for, by the way, good examples of traits, interestingly, look at Grails. Grails has implements a lot of their functionality in the infrastructure now in traits. So if you look at Grails controllers, they implement multiple traits, and it's a neat way to get a feel for what they're designed for and how they're used. That's always a nice use case, you know, to look and see how Grails does things. Don't see any other comments. Yeah, I'm expecting people, oh, something is going wrong in production. Well, hey, you've got a Spring application. Never mind. So,
I have a small question. Is Groovy 3 supported in SOAP UI and Postman already?
well, SOAP UI, I don't think has been updated seriously in years. So I'm not optimistic. I don't think it comes with it. I think they're still on 2. I don't know, 2, 3, or 4, one of those. But I haven't checked recently, so I don't know for sure. The other one you said was Postman, was that?
Yeah.
Postman, I've only seen used in browser-based stuff. I didn't know you could script Postman. I use HTTPie, PIE. Do you know that tool?
Yeah.
Yeah, which is an awesome tool, but then I don't care whether I'm using Groovy or whatever. I'm not scripting it. I'm just using the tool itself. So you know more about it than I do then in that case. I will say though that Spring is very comfortable with Groovy. And even though when you create a Spring app with Spring Boot and you say you want Groovy support, they still use 2.4 or whatever, but I've upgraded it to 3 and everything just worked fine. Any other questions, comments, anything else? You are a relatively quiet crowd, other than Eric, you know, who I expected, actually. Okay, well, I'll hang out for a few minutes in case you have any other questions, but otherwise, I think we're good. What I'll probably do, I'll probably take those slides and just upload it to the GitHub repository, you know, as a PDF, if you're interested. Oh, well, I'm glad that was useful for you. I hope that does help, and, you know, and hope you get a chance to use this stuff. And, you know, keep in touch. Let me know if you get to use it in an interesting app.
I got another one. Is Groovy 3 fully backwards compatible with Groovy 2, with Groovy 2 closures? Like how easy is to migrate Groovy 2 to Groovy 3?
I haven't had any problems at all. The one problem I had more trouble with Spock than I did with Groovy 3. When I took my existing Groovy projects and just switched to Groovy 3, everything worked cleanly. Spock, by switching to JUnit 5, required some additional work. But no, I didn't have it. Now, again, that's anecdotal. You know, I don't know what you're going to have in your production issues, but it doesn't look like, I mean, these are really all just additions and extra syntax that's compatible with Java. I don't think any of my Groovy projects have had any trouble at all moving to Groovy 3.
Yeah, I'm quite happy. I'm actually quite happy to see a few of these changes because it finally starts to look similar to Java.
Hmm.
Yeah, currently in the middle of getting out of Groovy, and this could make it easier. These changes could make it a bit easier.
Well, we don't want to make it easier for you to leave Groovy. I don't know. I still really like it. I wish the collect method was called map, but other than that, inject doesn't bother me. Find all is actually more intuitive than filter, because I run into Java people who go, wait, does filter mean include these things or exclude these things? Whereas, find all, well, that's really obvious,
Yeah.
But collect, and unfortunately Java picked the same word for a totally different meaning. That's unfortunate.
Yeah.
But everything else, I mean, I still like it. It's still my favorite, even though I spend more time in the Kotlin world. But that's not because I want to use Kotlin. It's because I'd want to do Android. And that's the definitive language.
It's definitely fun. It's definitely fun. I have one very big argument against Groovy. It's def used as parameters. It's just a horrible idea.
Well, do you mean putting the word def in there or just leaving out any data type and therefore it's assumed to be whatever?
Allowing Groovy to decide what the runtime type actually is.
If you don't like it, you can declare a type. See, that's the thing. I like having the power as long as you don't misuse it. I mean, great power comes great responsibility. So.
True.
And there's also code narc rule that can help you make sure that you don't do it if you don't want it, or if you have an agreement on the team that you don't use def in method signatures. So you can even enforce it.
Exactly. And there's @type checked, the ASD transform, and there's @compile static. In other words, if your company really decides to lock everything down, Groovy says sure. But Groovy's the only language I know that says if you want to lock it down, you can, and if you don't want to, you don't have to. And when you're parsing JSON data, what benefit does it get you? I mean, I see in Kotlin the knots people will tie themselves into trying to say, well, I don't know what this data type is. It's some weird kind of closure, and they don't care. And it's like, I'd love to just say def when I'm parsing JSON data, for example. It doesn't benefit me to know that this is some intermediate JSON node type, Yeah. But okay, again, it's my own opinion. I'd rather have, and then they say, well, how do I prevent my coworkers from causing damage? And I say, well, that's, you teach them to do better. That's not a bug, that's a feature. So whatever.
Yeah, I found a few nice quirky lines, quirky features that might be useful.
Yeah, I mean, it's just there's so much to it. I mean, just being able to do this is so cool. For example, where did I lost it. Oh, there. I mean, do you ever just say something like let's see, 1, 2, 3, comma, quote A, quote B, dot combinations. I mean, look at that. It's so easy. Or you could do something like ABC dot permutation. Wrong one. I did have to put it in a list, I guess. So A, B, C. There we go.
First comma to the right.
Oh, yeah. That's why I have my audio debugger turned on. There you go. I mean, these are things. Groovy's been around a while, and in fact, that's one of my frustrations with Kotlin is that there's a lot of things that are so much easier to do in Groovy, like delegates, for example. The @delegate is fantastic in Groovy. That's so easy to do. And in Kotlin, it's so painful to write your own property delegate, for example. But okay, if you're going to do Android, you're going to do Kotlin. You should see, if you do Gradle, by the way, you see that Kotlin DSL, it's not fun. And the Groovy DSL is easy. But the IDE support is not great and never has been on Gradle. So, okay. Anything else? Okay, well, I thought that was fun. I had a good time. I think I'm still the host. Ruslan, where's Ruslan? Oh, do you want to say anything about the group or anything like that? Or anything about anything else to say?
Well, thanks a lot about the talk. It was very interesting. I don't have other questions in Groovy. I'm not actively using it, but I'm enjoying it.
No, I'm just hoping that the London Groovy and Grails user group goes well, and that you get a lot of people, and that not all of them are trying to find out how they can leave Groovy and go back to Java. Sorry, I shouldn't be giving you a hard time. Oh well.
Yeah, I shouldn't give you a hard time either, but
please don't worry about it. It's a very friendly community, as I say. That's in fact.
And Groovy's very fun to write until things go wrong, and then you.
Yeah. Right.
Then you're trying to figure out how to get out of your multi-thousand or multi-dozen of thousand lines of production code, and
yeah, there's a lot of stuff going under the hood, right?
Mm-hmm. Spock is my favorite thing in Groovy, and if we were able to define tests in Java with JUnit with the same simplicity, that would be awesome.
Well, JUnit.
But apart from that, unfortunately for me, it's just JavaScript on JVM, which I'm not a fan of.
Well, Java 5 with the parameterized tests really closes a lot of the gap between JUnit and Spock. It's still not as good, but it closes the gap. And also the mocking framework built into Spock, I don't know how I feel about it, but it's still simpler than most things in Mockito, Yeah. So, right. And I agree, though, that, I mean, if your alternative is, oh, yeah, I'm going to write Node on the server side, it's like, no, I think let's use the JVM here, right? I think we can all agree on that, right? It's like the Star Trek and the Star Wars people arguing and say, well, let's just gang up on the Twilight people or something, Okay. Thank you all very much for coming. And as I say, I'll just take the slides and I'll upload a PDF to the GitHub repository. And you have the link to that, I think. Let me go back to that page here. Here it is, the Groovy 3 examples again. And I'll say thank you for coming.
Thank you so much.
Thank you. That was fun. I think I could turn off my screen share now. So.
Thank you so much.
Thank you. You didn't say much.
I think the questions which I asked, Raphael already asked. So yeah, I was about to ask the same question. Yeah, it was a good session. I was more keen on looking into the, what the Groovy 3 provides more, and it's good to see that we can use the same Java features. And yeah, it's good. Thank you for the question.
I think the way you said that is exactly the right way to think about it. It's that it just makes it easier to integrate with existing Java code and existing Java features. That's the big change, really. Everything else is gravy.
Yeah.
Just waiting for the last few people to say they've had enough.
Sorry for being a hater.
No, please. I'm glad I had somebody to talk to. That's more than happy to have you here. Thank you very much for coming. And you're not a hater. You just, blame it on your company anyway.
Actually, the usage of Groovy in my current company is very, very, very limited.
Yeah, most Groovy
just boils
projects
down to some fairly simple tool, but we are still migrating to Java because of mainly type safety, maintainability, and unification of the code base.
Yeah, and if you don't need memoization, if you don't need currying, if you don't need all these extra functional features that Groovy adds beyond Java, Java has improved, I thought, enormously in the past. Java 11 is actually a nice baseline now. I like that.
Yeah.
And when they added text blocks in 14, And the enhanced switch statement, which is still a preview feature, that's going to be nice too. Of course, Groovy's had both of those for years, but now they'll be in Java. So, okay. Have you looked at text blocks, by the way?
No, not yet.
Here's the weird part for you. After the initial 3 double quotes, you have to have a carriage return. You have to. You can't put in the initial text after that. It's got to be 3 double quotes, carriage return, lots of code, and then where you put the 3 double quotes on the close, however far you indent governs how much of the white space is significant.
Wow.
Bizarre. Yeah, exactly. Yeah, wait and take a look at that.
Yeah, so far I had a look only at the garbage collectors.
Yeah, it's a preview feature of 14. I think it'll be final. It might be in 15, which will be out in a couple of weeks, I guess. But the enhanced switch statement is really Groovy's switch, just with just very similar.
Yeah,
and it's much nicer.
It's good to hear that Groovy did something very cool.
Yeah, and the records in Java are going to be okay, but they introduced some weird stuff there, and we're going to see how that plays out too. Anyway,
yeah, we see.
Where are you based, by the way?
London.
Ah, very good.
And yeah, and I'm not sure how I feel about triple equals.
I think they got that from JavaScript, right?
More similarities to JavaScript. And
yeah. It's a visceral reaction, Hey, it looks like JavaScript now. I don't want this.
Yeah, and it was quite similar before already. So, in some ways, in a few spots. So,
yeah, in a few spots, but we'll see.
Yeah, thanks a lot. Presentation was great. Material is cool. Groovy 3 looks great.
Thank you, sir. That's very kind of you. Feel free to keep in touch. Love to hear what you think.
All right.
Of course, I'd rather hear what the woman. I don't know how to pronounce her name, so it looks like Swaroop, so I don't know what to say.
Yeah, you are right, Swaroop.
I'd rather hear what you have to say. Never mind. It was a bad joke and it didn't work, so never mind. I was trying to give him a hard time and it didn't work. So.
Okay.
But you said that you were going to say what he asked. That's why I was.
Yeah, I was more keen on asking about the backward compatibility. So he already asked that. So yeah.
And I tried to leverage that into a gag, and it, that's fortunately most people had left by that point. So.
Maybe it will work next time.
Okay, take care then.
Thank you.
Thank you.
Okay, bye-bye.
Thank you.